this is Schweitzer, and we're looking to do a little answer key video on drawing particular substances and showing the intermolecular forces. So this is starting to take the intermolecular forces and reapplying it more towards individual substances. So we're trying to show, include detailed indications of inter and intramolecular forces. Alright, let's do this. So we have liquid water. So liquid water is something that we've drawn quite a bit. So we just draw it as a liquid, and we just do H2O and another H2O like this, and we'd want to make sure we indicate that this is going to be a hydrogen bonding right here. Alright, liquid propane, we'll go this way. Just propane is C3H8, you could figure that out, looks like that. So liquid propane, which is inside a propane tank, would have just these guys here, just 3 carbon chains, and they would be sticking together via London dispersion forces. That's all we got for these guys. London dispersion forces. It's symmetrical, no highly electronegative atom dragging electrons to one side. Carbon dioxide dissolved in water. Okay. Key thing here is this is a molecule. So COO, if you want to draw like that, looks like this. C double bond O with like that. I would just abbreviate that like this, and I would just keep it together. Now the only thing really keeping this thing in the water there, it's symmetrical, is London dispersion forces, and make sure that because it's a molecule it stays together. You don't want to break the thing apart. Dissolved ammonia in water. So ammonia is NH3, and it looks like this, nitrogen, and it is not symmetrical, has a lone pair of electrons right here, making this side partial negative, this side partial positive. And therefore we have water molecules on like this, and we have an NH3 over here. And we'd have a little hydrogen bond right there. So this guy is going to be hydrogen bonding. Okay, you have another one here. And then moving along, liquid ammonia evaporating. Okay, so we have liquid ammonia. This is something that smells really bad, like, I don't know, like cat pee or something like that. Really strong smell if it's concentrated. So we have NH3, you could draw it like this. I might just do a little better job of that one. So N, because this thing is going to be hydrogen bonding as well. Hydrogen bond. And when it evaporates, I also would have a NH3 up here as its own little molecule floating up. Solid NaCl. Okay, now this is a ionic compound, so an ionic bond. And I'd want to just draw an NaCl just so we can be somewhat precise. I'm going to draw the cation a little smaller than the anion, just to show this as the chloride has 3 energy levels, where the sodium only has 2. I'm just going to draw this thing out sort of in the best bulk crystal that I can. I know that that's difficult to do of a 3-dimensional object. But we can give it a whirl. And this thing would form a 3-dimensional bulk crystal like so. Good review of that. And would go in 3 dimensions as well. Alright. And that ends our just a little brief crossover between bonding and states of matter. Thank you very much.